Are you okay with the count?
I'm fine, yes, I can hear you, so that's fine.
Okay then. In 3, 2, 1.
Good afternoon. It's a mixture of showers and sunshine, really, because we still have these northerly winds, quite cold winds, in fact. High pressure just occupying the middle of the Atlantic, stopping any mild air coming along for a while. So it's a cold day again, quite a strong wind, bringing some wintry... My career started when I left school with A-levels in maths, physics and geography. Didn't really know what I wanted to do, but felt it would involve science of some sort. And I was looking in one of the career booklets, and the Met Office, the meteorological office, came on the list. I thought, now that's something nobody else has mentioned, really interested me, joined up, and I've been working in meteorology ever since. One of the first things that has to happen to make a weather forecast is to observe the weather. We need to measure where everything is before we can analyse it and predict where it's going to go to next. For example, this chart here shows plotted weather reports from all around the British Isles, and one of my first jobs when I come in on a shift is to draw isobars, which joins the lines of equal pressure, and as many will know, the spacing of the isobar determines how quickly the wind is blowing. The charts that I draw in the office here don't actually get on the screen. I think they're works of art. I think they could stand their ground there, but no, the charts that you see on the screen are the results of the mathematical models calculations of how the atmosphere behaves. If you can imagine the world is split up into lines of latitude and longitude in our weather world. They're not latitude and longitude, but they're crossover lines. And the spacing of these grids of lines where they cross over determines the resolution of the model. At midday, for example, all of these values, these readings, are combined into what we call the initial field of the model. We'll see that the model has areas of cloud and rain, and it's taken those grid points and it said there's rain at that point at that time, or there's cloud at that point at that time. Now that's the result of a very state-of-the-art model on your television sets. 40 years ago, we had no idea that we could get that sort of luxury of resolution. And there are models like this available on the internet at home. You could go home and you could go into your school IT lab and you could call up the results of these models and see how the equations are being solved to produce values of complex things like the weather. I think the thing that makes weather forecasting so appealing to me is that I look on it as a physics experiment. And when you're at school, you'll go into the physics lab for a practical, and a new experiment will be set up and you'll deal with it and learn something from it. I have a new experiment in the subject that I love to deal with every single day. It's a new experiment been set up, and the physics that's operating in the atmosphere is different each day, and I have to determine what those rules are and apply the mathematics to that problem to solve which particular bit of physics we need to look at most closely. And it could be to do with heat exchange, forecasting at what rate the temperature will fall, how quickly, for example, the roads might go below freezing and make them icy. It could be to do with how fast the winds are blowing, forecasting for aviation, deciding how quickly the headwind is blowing against an airliner flying across the Atlantic. It could be how big the seas are going to be. If you're sailing on a ferry across the North Sea, you have to make calculations to work out how big the waves will be. All of those things involve the use of mathematics and the use of physics, and it's different every single day.